round two. We're going to finish up the hard problems, and then we might go to a couple. I'm doing all the problems that were mentioned by at least 3 people, and if we have more time, we'll go to the twos. All right, number 25 was next. It's piecewise. It needs to be differentiable. So if it needs to be differentiable, we have to make sure it's differentiable and continuous at x equals 2. So that means that if I plug 2 in, it would work. But let's do f prime first. I think that might be easier. So f prime of x is going to be just plain old c for x less than or equal to 2, for x less than 2, and it's going to be 2x minus c for x greater than 2. Actually, that was equal to. And these derivatives need to come to the same value on either side of 2. So we need to make sure at 2 they would be the same value. So when x equals 2, then c, whatever c is, has to be equal to 4 minus c. So 2c equals 4, so c equals 2. Awesome. I need to know d also. So we have to look at continuity to make sure it's also continuous. So we know c is 2 now. So 2x plus d has to give me the same value as x squared minus, I'm plugging in 2 for the c's, 2x. When x is equal to 2, these have to be the same. So 4 plus d has to be equal to 4 minus 4, which is 0, right? Because x is 2. Yep, that makes sense. And so 0, so d is negative 4. So c plus d looks to me like it's negative 2. Got an answer? Moving on. Next one is calculator question. I got my calculator. It's number 92, and then we're going to go back. This is the last one that was mentioned by at least 3 people. Here we go. Okay. Ooh, interesting. All right. The figure, I don't think I need my calculator for it. The figure above shows the functions, the graphs are tangent as shown. B of x equals b. So this is a great example of trust the symbols answer I'm going to give. Is it says b of x equals that thing. What's b prime of that? I have no idea how to use this stuff up above right now, but I'm just going to jump into it and say, well, I need b prime of negative 3. Well, okay. So b prime of x is g prime of f of x times f prime of x, just using chain rule. So b prime of negative 3 then has to be g prime of f of negative 3 times f prime of negative 3. And the key on this one, okay, I get where this is going. And so the key on this one is I didn't know what I needed to do with this thing. I had to just go with the symbols and say, well, I don't even know what I'm looking for. Now I know what I'm looking for. I need f prime of negative 3. Well, here's f of x right here, and f prime, it's linear, right? Didn't say it's linear specifically, but boy, it looks like it, and I imagine that's what they're kind of implying on this. So f prime of negative 3 is just a slope at negative 3. What's a slope? The slope is 1/3. Okay, positive? Yeah, positive. Okay, and now g prime of f of negative 3. So what's f of negative 3? F of negative 3 is 1, so I need g prime, well, at 1. And that's why they gave me this thing over here. The graphs of the tangents are at x equals 1. Yeah, so this is the tangent line at 1. And that looks like it's a slope of negative 1/2. So it's negative 1/2 times 1/3, which is negative 1/6. And I got 1 of the answers, so I'll check it. I mean, definitely, I've done these pretty quick, and I could check my work on them, but I felt pretty good about those. And so on a first pass, I definitely move on. All right, I think what I'm going to do is now I'm just going to go and see any of the questions, especially if it looks, I mean, I'll just look at the questions that were mentioned by at least 2 people, and then and see if I have any, I mean, I might skip one if I look at it and go, I don't have too much to say there. So number 6. All right, so, okay, so this is equal to, that's a graph with a hole in it, so that's x plus 2. So what does this thing look like? It looks like y equals x plus 2, except when x is equal to 2, then it's got a hole in it, and otherwise at 2 you're at 1. So that's what the graph looks like. I can't erase just inside there because I'll just erase the line, right? Yeah, I don't know, but that should do. So so what's going on? Does it have a limit? Yes, it has a limit because it's coming together. That doesn't matter. Is it continuous? No, therefore it's not differentiable. Answer A. Next one, number 13. 11, 12, 13. There we go. 13. Oh, integral. Okay. Yeah, it looks pretty straightforward. I should divide it in 2 fractions. So it's the integral from 1 to e of x plus 1 over x dx. I mean, if you don't write this, it's multiple choice. It doesn't matter, but I'm just trying to be all teacher-like. So it's x squared 1/2 plus natural log of x. Don't need absolute values because it's all positive. 1/2 x squared, that looks good. And evaluate this from 1 to e, so plug in e, so that's 1/2 e squared plus natural log of e, which is 1, minus, plug in 1, 1/2 1 squared, which is 1/2 plus natural log of 1, which is 0. All right. Okay. So I've got 1/2 e squared. Sorry about that notation there. Plus 1 minus 1/2 plus 1. It's got to be common denominator, right? So common denominator of 2, and that'd be e squared. That'd be 2 over 2. So e squared plus 2 over 2. Yeah, there you go. Okay, next one. 17. I need f prime of 2. Okay, f prime of x is, chain rule, h prime of x squared minus 3 times 2x, and which is f prime of 2. Plug in 2, so that's, plug in 2, 4 minus 3, which is 1, so h prime of 1, oh, I can see all this, times x is equal to times 4, 4h prime of 1. Looks good. Next one, well, that was 17. 19. Oh, partial fractions. Okay, so, ooh, and with a 2x, making it tricky for us. All right, so it's a over 2x minus 3 plus b over x plus 2 equals 7x. So it's a times x plus 2 plus b times 2x minus 3 equals 7x. I mean, it's 7x over the denominator. All right, and so let's make x equal to, wow, x equal to -2. So when x is -2, it goes away, -2, so that's negative 7b equals x is -2, -14. So b is 2. And then we make 3/2. Man, is there an easier way? Probably is, but I'm just going to do it. So x equals 3/2, because when I plug that in, that would go away. Yes, it would. So a times 3/2 plus 2, which is 7/2. Ooh, I see the 7. That's cool. Equals 7 times 3/2. And so multiply both sides by 2. Divide by 7. A equals 3. So do I have room? Yeah, I got room. And so it's, make sure to put the right thing over the right thing. It's 3 over 2x minus 3. Plus, plug in 2 over x plus 2, and integral dx. Now let's find the answers. So I need 3 natural log of x, 3 natural log. Okay, I'm liking these guys right here, so I'm looking at those, because those look, oh, wait, no, very sneaky. So I'd pull the 3 out, but then to do the derivative of this, I mean, to do the integral of this, that would be the integral of 3, and then it's 1 over 2x minus 3. And to say that this is natural log 2x minus 3, I need a 2 out here, so I have to have a 2 out there also. Therefore, the correct answer is A. So one great example there of, would I have spotted it if it wasn't multiple choice? I could have made that mistake because I'm trying to work really fast, mostly because of my video limit time. But But because the multiple choice answers that reminded me of something that I might have just forgotten about otherwise. So that was kind of handy. 19 done. 27 is the next one. Again, some of these were missed by one person. You might have just done a silly mistake on one, so don't feel bad if yours doesn't get brought up, because it means either you handed in late, which is a possibility, or you're the only one who made that very creative mistake that you made or something. Slope field for this. Okay, so what I notice, x doesn't matter. X isn't in here at all. So for any given y value, the x isn't going to be important at all. So we need at any given y value, the slope would be the exact same thing. Yeah, that's one thing. The other one I'm going to notice is when is dy dx equals 0? Dx equals 0 when y equals plus or minus 1. So I need flat at 1, flat at -1, and then at any x value it needs to look like the same thing. So flat at 1. Okay, flat at 1 and flat at -1, and the x doesn't matter. So, I mean, I have my answer, but it's kind of funny because of the units they used, they don't actually have it be flat at 1. It's a little off from flat, but it's just because of the units they used that it does that. And so I'm checking A. 27's done. 85, 87. Then I'm done. Oh, man, maybe I can make it. Here we go. Again, these answers might not be correct yet. Look at the post. I'll put if the answers are correct or not. Particle moves by that. How many times does the particle change direction as increases the next 3? I need to plug this thing in. Clear. So it's 3x. I'm pausing it because I want to make it. Okay, so I graphed it. It looks something like this, and then I want to know what was going on in this little part right here. So I graphed it. Hey, there we go. So I graphed it. I made the x's go from -3 to 3, and then I zoomed in the y's a bunch of times. And if you notice really closely, there's a little space right there, and there's a tiny little space right there. But that might just be a pixel issue where it's not plugging in the right number to hit that spot. But it definitely didn't go above the axis during that time. So it's not changing direction at that moment. So it's like, when does it, how many times does it change direction? So it's got a positive velocity because this is a velocity graph. It's got a negative velocity. It's 0 for a moment, but it didn't change direction because it kept going negative. Or maybe it's not 0. I can't really tell. I mean, I could spend more time, but I'm not, I wouldn't, to be honest, once I saw this graph. And then it goes positive in the end. And so it only changes direction twice is what I'm seeing on mine. This is definitely one I'd spend more time on if I wasn't trying to end in 15 minutes here. So because, maybe I'm missing something on the graph and I'd want to like zoom in really well, or maybe set them equal to each other, equal to, and put in a line at 0 or find the zeros on it and see if is there a 0 on there or not. But I'd move on. All right. Last one is 87. Yep. I'm going to make it. Okay, an object is traveling. The initial position is x equals 2. The velocity is that. What is the position? So it's starting. So at 0, okay, you've got this velocity curve, and this velocity curve starts at a velocity of 1 and gradually increases. I'm not going to think too much about it, but it looks like it's a 2/3 power, and it's increasing up until 3. So, and so, yeah, I'm going to make it. And so this is the velocity curve. We want to know what the position is at time t equals 3, and we know it started at 2. So the position x of 3 is going to be is equal to 2 plus the integral from 0 to 3 of the velocity curve, because this will tell us how much it moved. So I'm going to do this on my calculator right now, and then add 2 to it for its initial position to find out what the new position is. But I'm going to do this with the screen paused. Oh, sorry. Here's what I typed in. I integrated it from 0 to 3, and I typed in the function. You could have put it in a y1, but I thought it's a pretty easy function. It's not too bad, so I just put it in the integral. It says the integral is 4.512, but remember, it started at position 2, and they don't want to know the change in position. They want to know the final position. Therefore, the correct answer is D. And those are all the multiple choice questions, I think. I apologize if I missed one, that were asked by at least 2 people. Other answers posted online, and that's it. So there's your 2008 Weird Questions review.